All right, so let's consider this simple problem. I have this seesaw. So I have a board. It has a certain mass, and it's pivoted about this point. Um, I have a little girl over here. She has a mass of 50 kilograms. I have a little boy, a big boy actually, who has a mass of 100 kilograms. And the little girl is 2 meters from the axis of rotation, and I want to know where does the little boy stand so that he is, so that the board is balanced. Now I know that the torque 1 has to equal torque 2, but I'm going to write that a little bit differently, and I'm going to say that in order for this to be true, in order for this to be in equilibrium, that the sum of the torques has to equal 0. All right, torque 1 over here is causing motion in this direction. That is counterclockwise. So the sum of the torques will be a positive torque 1 minus torque 2, because torque 2 causes it to go in this direction, which is clockwise, and that has to equal 0. I know that my torque 1 is Fw1 times R1 minus Fw2 times R2. That's equal to 0. Fw1, let's see, what was she, 50 kilograms times 10, I'll call it, meters per second squared, times R1, which was 2 meters, minus 100 kilograms times 10 meters per second squared, that's G. So I'm just getting the weight here, times X. And that's equal to 0. And then if I solve that for X, let's see, I get 500, 1,000 divided by 1,000. X is 1 meter. You can see that up here, and you could probably look at this almost and tell I have twice the distance here, and I have twice the mass here, so I'm going to need just 1 meter here. All right, so that is my sum. That comes about from the sum of my torques equals 0. Now, if the mass of the plank is 10 kilograms, I also want to know what is the normal force. That is, what is the force that is acting here on the pivot that points up. Right? And in that case, I have to include all the forces. And this is just like what we did previously. That is that the sum of the forces equals 0. The forces up are just going to be the normal force. And then I have several things. I have the weight of the plank. That's one force that's down. Minus the weight of the little girl. Minus the weight of the little boy. And that has to all equal 0. So this other criterion has to be met, that the sum of the forces equals 0. And then I can solve for the normal force. So the normal force equals the mass of the plank, which was 10 kilograms, times G, plus 50 kilograms, that's the mass of the little girl, times G, plus 100 kilograms, times 10. That's the mass of the little boy, the weight of the little boy. That gives me 100 plus 500. Oh, I'm sorry, this should have been 10 over here, so this is just 10. That's the, no, I'm sorry, that is right. This is the mass of the boy. This is the mass of the plank, mass of the girl, mass of the boy. So this gives me 100 plus 500 plus 1,000 is 1,600 newtons. So this is a very simple problem, a static problem, where you have to consider not only the equilibrium of the forces, but also the equilibrium of the torques. All right, now let's pause there.